Welcome to TechBrothersIT. In this video, we are going to take a look into the dedicated SQL pool. A dedicated SQL pool in Azure Synapse Analytics, formerly known as Azure SQL Data Warehouse, is scalable, MPP, massively parallel processing data warehouse solution that provides high performance SQL based analytics. It is designed for structured data workloads and offer complete control over compute and storage. And here are some important features. So previously we known this as Azure SQL Data Warehouse, available as standalone service or integrated with the Synapse Studio. You can also go to the portal.azure.com and here you can look for dedicated pool. So you can see right there, formerly SQL Data Warehouse. You can go ahead and create it. Doesn't have to be created in the Synapse, but we are going to create in the Synapse Analytics. But this can be created as separate service as well. Now here traditional SQL database, so it works like a SQL server. You have SQL server, but the architect is the MPP, massive parallel processing. In SQL server we don't have that feature, so this is way faster than your SQL server. Now what elasticity, you compute and the storage scale independently, so they are not together. And in SQL server we know that we have a storage that's connected with SQL server, and here they are totally scale independently. So you can have more compute whenever you want to. You can the storage is not depending on the compute, and there is no licensing happening, like you have more cores, then you have to pay more for the cores for licensing and all that. That's not here. You can go ahead and just simply increase your compute, run your queries, and then you can also decrease your compute. Cost saving feature, you can pause and resume the service to save cost, so that's also possible. And that's really great feature, especially if we are not running our queries. We can always go ahead and pause the compute, and that will help us to save some money. Now, what are the core components of dedicated SQL pool? So the one is called control node. It acts as a SQL endpoints for all user connections. And then you have compute nodes run the actual query operations in parallel. Then you have distribution, so the table data is distributed or split across 60 fixed distributions. And data movement service that manage the data shuffling between the nodes. So you have all these compute nodes if they're running a query, and then if they need the data from other nodes, then DMS is going to get them that data. Now here is the picture. You can see all the details, and you have application or user connection, and then that's connected to the control node. You have DMS here, and then massively parallel processing MPP engine, and then you have compute nodes attached here. So each compute node, the SQL query will be split into it, and then they will get the SQL and then run against the Azure storage. DMS will help them to move the data between the nodes if it is needed, or back to the control node if it is needed. Now let's take a look on the query execution flow. So user or application send the query. The query is submitted to the control node, which serve as a single entry point for all requests. So that's what we see right here. You have your application or users, and they are going to the control node. Then you have a control node parse and optimize. So once the control node is going to get the query, it's going to parse and optimize. The control node processes the query, generates an execution plan, and determines how to split the task. And the next MPP engine dispatches the task. So massively parallel processing MPP engine within the control node breaks the query into smaller steps and send them to the multiple compute nodes. And once those will receive the query, the compute node execute in parallel. Each compute node runs its part of query independently across data distributions stored in the Azure storage. And the data movement service handles transfers. If data is needed from one node for joins or aggregation, DMS moves it as necessary. And results aggregated and returned. The control node gather results from the all compute node, assemble the final output, and return to the user or the application. So that make it really easy. All the steps I have explained, what you have seen in this picture, and now we know what exactly is the control node, what is the compute node, and how the storage is, and how they work from step 1 to all the way to the end. Now let's talk about the distribution in detail. We were talking about like, hey, you have a table and how it is distributed. So distributions are how data is physically divided across the compute nodes to enable massively parallel processing in a dedicated SQL pool. Each table, when we create it, we have to tell like how we want to distribute that data on the storage. Each table must specify a distribution method which determines how the rows are spread across the 60 fixed distributions. So now when we create the table, you have to tell either you have a hash, round robin, or a replicator. So you will be telling one of them. Now what is hash? Rows are assigned to the distribution based on the hash value of a specified column. The method is optimal for large fact tables and improves join and aggregation performance when used consistently across related tables. So think about a scenario when you have this type of situation, and then you're going to create a table with the hash. Now if you will go like say rows are assigned randomly and evenly across all distribution. This method is useful when there is no clear join key or staging tables, but it may result in performance inefficiencies for joins. So think about that. Maybe for staging tables, you just want to throw those records across all the distributions, and you can use round robin in that scenario. And replicate the entire table is copied to each compute node. This is intended for small dimension or lookup tables used frequently in joins, reducing the need for the data movement between the nodes. So you will be using replicate in those kind of situations. Each table explicitly specifies the distribution method during creation using distribution clause. So you have to provide that, and that will be you will be using a distribution. We will create multiple tables, and I will show you in the demos how exactly distribution will work. But now the thing is, you need to remember you have to study your data before you create the table, and then once you have knowledge about your data, then you will be able to use the right distribution method. Now let's take a look on the data warehousing unit. So data warehouse unit is equal to the CPU and your memory and IO. So together they make one processing unit. Represents the computational power of the dedicated SQL pool. You can increase or decrease the number of DWUs based on the performance needs. Here are some different types of the DWUI levels, and here you can see that we have DW100C, that is a one compute node and a 60 GB RAM. Now for the 200 you have a one node, but you have 120 GB RAM, and it keep increasing. But as the nodes increase or the memory increase and the numbers increasing, also the price is going to increase. So you want to make sure you are aware of this. Like it's not just you can go ahead and increase the DWUs and then you will be like, hey, it cost me that much, my bill is really high. So you got to be careful when you're increasing, and then also always pay attention once you are done with executing your queries. Always pause it if you don't need it. Now let's go to the different features supported and not supported in dedicated SQL pools. So tables, views, indexes, and schemas are supported. And if you remember in serverless SQL pool, we didn't have the tables. We had external tables, but we were not able to create the tables. Here in the dedicated pools, it's think about it's pretty much like your SQL database where you can create pretty much all of the objects. So you will be able to create the tables and then query and whatever you want to do with them. You will be able to do that. Store procedures, functions, temp tables, statistics are all available. DDL and DML statements can be done. Dynamic SQL can be done as well. And dynamic management views are available as well. What's not available, that's the triggers and the cross database queries. And then there are some differences in SQL Server and then Azure Synapse dedicated pool. There are constraints, that's a different identity column and relationships. I'm going to show you all these one by one later on in the videos. Now benefits of dedicated pool: high scalability for petabyte scale data. So that's important. In a SQL Server we don't have that, so we are always struggling with the increase the disks, or then when we have a large size of the databases, then sometimes we don't have enough compute. fine-grained control over performance and cost. So we can change our DWUs units depending upon our scenarios, and anytime we can increase or decrease, it's our choice. And we can, for heavy loads, we can increase, run the query, and then decrease back, or just pause it. Now, ideal for structured data and large reporting workload, and full T-SQL support including DDL and DML. So that was the introduction to our dedicated SQL pool in Azure Synapse. I hope you learned some basics from here, and now we are going to go ahead and jump into demos and perform different tasks with the dedicated SQL pool in Azure Synapse. So I thank you very much for watching. Please subscribe my channel, and I will see you guys in the next video.